And part 2 it is. Alright, turn the timer on. How about that? Alright, so the function I want to investigate is x squared plus 1. So we know what that is. It's a parabola raised up 1. And I want to find the slope of this parabola anywhere. We'll come back and use our rule, say at x equals 2. So I want the slope here of this value. And then maybe we'll look at it at x equals minus 2. We would expect a similar answer with a different sign. But right now we'll just come up with the rule for any point on this parabola. So we're going to do f of x plus h minus f of x divided by h and take the limit as h approaches 0. So that secant becomes a tangent as that h shrinks away. So let's do the work. Limit as h approaches 0 of f of x is x squared plus 1. So what's f of x plus h? That is the x takes on x plus h everywhere. So we have x plus h quantity squared plus 1. That's this part. Minus f of x is the function. And watch that negative sign. It will change everything behind it. Divided by h. Alright. This kind of work looks familiar, I'm sure, from last year. And when you square that, and you distribute the minus sign, the fun begins. X squared minus x squared. This was wrong. This was, oh, it wasn't. Okay. Plus 1 minus 1. There we go. So what do we have left? Gather our terms. The limit as h approaches 0 of 2xh plus h squared over h. Alright, so more fun. Each term had an h in it, so I could take those away. And what's left? 2x plus h. So now we're going to take the limit as h approaches 0 of 2x plus h. So this takes on a 0, and we end up with just 2x. So the whole limit was 2x. That is our rule. We will use it to find, so this 2x, the slope of the tangent on our curve for any given x value is 2x. All right, so we'll go back up here and answer the question I originally proposed. So what is the slope of this tangent line at x equals 2? Well, the slope of the tangent is 2x. So when we put a 2 in, our value for x is 2. When we put a 2 in here, we get 2 times 2. 4. So the slope at this line is m for slope equals 4. What about this line at minus 2? Well, we take 2x and we're going to substitute in our chosen value for x is minus 2. And the slope is minus 4. We can take, it's quite amazing, we can take any point anywhere on this function and find its slope by this rule 2x. So if I go out here to 3, the slope is 2 times 3. If I go back here to minus 1, the slope is 2 times minus 1. Alright, so what I've revealed to you is a new idea. It's a huge idea, And the slope of a tangent, a rule like that, is called the derivative. All right, so the derivative is the slope of a curve at a given point. So that's really all I want to say tonight, and just get our feet wet, and we will certainly build on that. Tomorrow when you come in, you can ask some review questions from the first chapter, but we're going to go ahead and do some problems like this. We're going to use the limit definition of the derivative and find the derivatives for various functions and use those rules at points on the curve. All right, till then, we're over and out.